All right, so let's look at another example of simplifying. Here I have something that looks already fairly simple, 1 over 1 plus sine x. And that's my given part of the equation, and I want to simplify it. Now I want to caution you on this. Whenever you have this 1 plus sine x in the denominator, you are not allowed to split up the denominators. You're only allowed to split up the numerators with the exact same denominator. So do not split this into 1 plus 1 over sine x. Do not do that. That is completely incorrect. So when I look at this, one of the strategies we learned was, well, I need to write this in terms of everything in terms of sine and cosine. Well, this is already in terms of sine and cosine. So I don't really have a clear-cut avenue on where to start at. So I'm going to show you a trick. I'm going to introduce something to this expression. Now in math, there's only two ways that we can introduce something into an expression correctly. We can add 0 or we can multiply by 1. By adding 0 or multiplying by 1, we don't actually change the expression, but we could change the way it looks. And that's what we're going to do. But I want to multiply this by the number 1. I'm going to introduce something. And what I want to introduce is what's called the conjugate of my denominator. Now, you learn in Algebra 2 about complex conjugates, how the sign in between changes. Well, this is not a complex conjugate because there's no complex, there's no I. But it does have a conjugate of 1 minus sine x. So what I'm actually going to do is I'm going to do 1 over 1 plus sine x. And I'm going to multiply it by the number 1, which is going to be 1 minus sine x over 1 minus sine x. Because this is still just the number 1, and I can do this. It doesn't change my expression. And this is just multiplying by the conjugate. All right, from here, the bottom, it multiplies nicely, and you'll see why we do the conjugate. The top 1 times this gives me just 1 minus sine x over, well, 1 plus sine x times 1 minus sine x is 1 minus sine squared x. And this is just multiplication. All right, 1 minus sine squared x, that's a Pythagorean identity. Because if I have sine squared x plus cosine squared x equals 1, I can solve for sine squared x, and I get cosine squared x. So I get 1 minus sine x over cosine squared x. This is just simply a Pythagorean identity. All right, from here, I'm allowed to split the denominator as long as I have the exact same. I'm allowed to split the numerator as long as I have the exact same denominator. So I can do 1 over cosine squared x minus, and I'm going to split this one up, sine x over cosine x times 1 over cosine x. I can do that because cosine times cosine is cosine squared, and this is just split. You can write the word split on there. I'm perfectly fine because you're just splitting it up. All right, well, 1 over cosine squared x, that is a reciprocal identity. This gives me secant squared x. Sine over cosine, well, that's tangent x, and 1 over cosine, that is secant x. And this is the reciprocal and the ratio. Now, I know you can factor out a GCF from here and kind of go from there, but you can leave it right here at this point, because at a certain point, you're just going to have to get a feel for where to stop. You could factor out the secant, but you're not really doing anything at that point. This is the simplest we're going to get this. All right, so let's look at, let's jump into verifying the really fun ones. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.